All right, good afternoon. My name is Mark Erikson, and today I am very excited to share with you a relatively brief guide to React rendering behavior. Yesterday, Ankita gave a great talk about performance and when you should think about things like use memo and use callback. This will hit a few of the same points, but it's also a little more detailed, a little more technical. For those of you who know me, this should be no surprise. I am a senior front-end engineer at Replay, where we're building a time-traveling debugger for JavaScript applications. We've got a booth back there. Please come by and talk to us. I'd love to show you how much easier time travel can make understanding problems in your code. I am an answerer of questions. I'll answer questions pretty much anywhere there's a text box on the internet. I collect all kinds of useful-looking links to articles and resources. I am a writer of extremely long blog posts, and I am a Redux maintainer. But most people know me as that guy with the Simpsons avatar. One quick announcement, Redux Toolkit 2.0 is in beta right now. We've got some new features, we've got some performance improvements, smaller bundle size. We would really appreciate feedback, people trying it out in your actual applications. Let us know how it works, what breaks, what we can improve. It's probably going to be several months at least until the final version comes out, because, you know, doing this in our spare time. All right, so what is rendering? Rendering is the process of React asking your application components, what do you want the UI to look like at this point in time based on your current props and state? And when we write components, we're usually writing them with JSX syntax, you know, angle bracket my component. But that actually has to get converted into function calls to react.createElement or a newer equivalent to that. That happens during the build process. So at runtime, createElement takes the component type and the props, and it returns an element object, which really just formats the data, so it's got a reference to your component type and the props and any children that you want inside of that. So during rendering, React is going to call all of your components, ask them to output these elements, and these form a tree of what the UI should look like at this point in time. You might have heard the phrase virtual DOM, and that's really all this is, a tree of objects describing the UI. So React is then going to look at this tree of descriptive objects and compare that versus what you said it should look like the last time. And this is called reconciliation, figuring out what things have changed. Every time React renders, it kind of splits the work into two distinct different phases. The first phase is called the render phase, and this is when it's actually looping over all the components and calling them, collecting those element objects, and doing the diffing work. React can actually split up the render phase into smaller chunks, pause it, resume it later, or even throw away some of the work in some cases. Once it actually knows what changes need to happen, it goes through the commit phase, where it actually knows here are the changes we need to apply to the DOM. Go ahead and execute all of those synchronously. At the end of the commit phase, React then runs some of the lifecycle methods. It runs your use layout effect callbacks, or the old style class component, like component did mount, component did update. And then your use effect hook callbacks run on a short timeout after that. By the way, as a side note, my slides are available on my blog. I threw a link into the talks channel on the Discord if you want to pull them up. Every React render starts with some kind of a call to set state. Today, that's mostly the set state functions from the use state hook or the equivalent dispatch function from the use reducer hook. In class components, it's this.setState or this.forceUpdate. There's also a couple other ways to trigger an update. You can actually call the top level React DOM render function again, and it's kind of like a set state in a non-existent parent component, roughly. And then there's the useSync external store hook, which is meant for use with libraries like Redux or JuStand or Jotai. Now, there is no force render function for function components. So the equivalent for that could be like a use reducer hook that just automatically increments a counter every time and doesn't even care what the current value is. So one mistake that people often have is they think that rendering implies that there must be an update to the DOM. And that's not true. Rendering is figuring out if there needs to be any updates to the DOM. It's entirely possible to have a render where the output is exactly the same as it was last time. There are no changes that need to be made, and nothing happens. So rendering is not a bad thing. It's how React works. It's how it knows if anything has to change. Now, React is inspired by some functional programming type principles. And so because of that, there are some rules that React components need to follow when they render. So there's a couple terms here. React components and their rendering process needs to be pure. There needs to be no side effects. Well, what's a side effect? A side effect is anything that affects the state of the world outside of this function as it runs. It could be mutating a variable that exists in the module scope, mutating a prop, making an async request, triggering a timer. Technically speaking, console logging is a side effect. It's just a side effect that doesn't actually hurt anything. Sebastian Markbaga, one of the React lead architects, has a gist where he laid out some rules of rendering. And these are things like you must not mutate existing variables, you shouldn't have random numbers in a component, you shouldn't make network requests or set state. There are actually some weird exceptions to this, like technically suspense. You're probably kicking off a network request while rendering. There's some oddball stuff here. You are allowed to do things like mutating variables that got created in the rendering. Like those haven't leaked to the outside world. It hasn't seen the results yet. One thing to note is that this does include hook bodies as well, because a hook body is really code running at the top of the function component. I actually just this week saw an example where a real application was leaking a keyboard event handler setup in a hook. It was recreating event handlers every time it rendered so that a single keystroke, if you had the app open for a while, would actually end up kicking off hundreds of event handlers for a single key because they never got cleaned up properly. So you do have to watch out for that sort of thing. Now, we know about function components and class components and even the really old React create class way of defining components. But in a very real way, those aren't even real. Those aren't actually the component. React keeps all the data about every single component instance in an internal object called a fiber. And you might have even heard the term React fiber. It was both a code name for the work that went into React 16, but also the name of this internal data structure. So if I render a to-do list component with 10 to-do list item components inside, React is going to create 11 of these fiber objects, one for each component instance. And it keeps track of what is the type of the component, what is its current props, its current state, any of the hooks that are attached to it, children, siblings, and a bunch of other internal data. And so these represent the actual current component tree. Now, when React is trying to figure out what's actually changed, it takes a couple shortcuts to speed up this process. And one of those is, if you change the type of the component at the same spot in the tree, it just assumes, oh, well, this has changed. Everything inside of there has changed. Let's just blow all that section away and recreate it from scratch. But that means you do have to be careful. One mistake I often see is people try to create a function component type inside of rendering another parent. And that's a problem because you're going to create a new function reference for the child every time the parent renders. And every time React is going to think, well, this is a brand new component type. I've never seen this before. Let's just recreate everything under there from scratch. And it's going to destroy all the children, all the DOM nodes, and blow it away. So you should never create component types while rendering. Each of those should always be at the top level, so it's the same function reference every time. Another way that React controls the component tree is with keys. Now, you've probably seen these with lists. If you don't include the key, React's going to print a warning. And that's because if you create a whole bunch of components of the same type, and then they change, React needs to know identity. So if I've got those 10 to-do list items, and I don't know, delete one to-do list item in the middle and add 2 more at the end, like, did I add and remove? Did I move them around? Did I just change the contents? So it needs to know which of these is which, so it can preserve the ones that actually need to stay alive and delete the ones that should have gone away. Keys are really instructions to React. In fact, you can never have props.key because React will actually strip that off every time. So keys should really be, ideally, unique values coming directly from the data itself. Never, ever use random numbers generated while rendering as keys, because those will always be different, and tell React to destroy that data and recreate it. You can also use keys for things like forms. So maybe you've got, I don't know, like a list of some items and a form with some details. You could apply a key on the form to tell React, okay, like go ahead and get rid of the form and recreate it later as you select something. React has always tried to optimize rendering. So if you call setState multiple times, it tries to batch those together in one render, but it does depend a little bit. In React 17 and earlier, it only did this when you called setState multiple times in an event handler. In React 18, it always tries to batch this, even after an async await or a promise callback. So in React 18, this batching behavior is on by default, and then there is a method you can use to opt out of it. Another problem I often see is people try to set state on one line, and then they try to make use of the new value on the next line. And this is a problem for a couple reasons. One is, like, the common phrase that I hear is people will describe it as setting state is async. And technically, sort of, kind of, not exactly. The call to set state is synchronous. Like, next line, done. But React hasn't actually rendered yet because it's going to wait for the end of the event loop to do the render. And second, especially in a function component, this is a closure. It is a snapshot of the state at the last time it rendered. This function reference can never see the new state because the next render hasn't even happened yet. So I know people keep wanting to do this, and it's really hard to like wrap your mind around the way this works, but trust me, that will never work properly. There are a few different edge cases. If you set state in use layout effect or the class component lifecycles, that will run a render pass immediately and synchronously because React wants to give you a chance to re-update the DOM before the JavaScript ends and the browser has a chance to paint. Also, React reconcilers like React DOM and React Native do export a couple functions that let you alter the batching and the timing. In the earlier versions of React, there was an unstable batched updates API. In React 18, there's now something called flush sync, which opts out of the batching. Another one that probably a lot of us are familiar with is strict mode. So if your component is inside strict mode and it's a development build, React will double render your component And the idea is that by doing this stuff twice, it'll probably make bad approaches break somehow. Often things to do with timers or effects. So like if you have like a console log in a component, you're going to actually see it show up twice instead of once. So you have to watch out for that sort of thing. And finally, this one really blows a lot of people's minds. It is legal and even correct to sometimes call setState in the body of a function component, but you have to do it conditionally. So there are a few cases when you might want to like copy a value from props to state. So you can do a comparison and like if they're different, call setState. And as soon as the component is done, React will actually loop back around and re-render it with the new state value right away, kind of pretending the previous attempt didn't even happen. So it is legal to do, but only in certain cases. So we said earlier that there's times that the render output might be exactly the same. And this makes sense because components are supposed to be literally a function of the props in the state. Same props in state should result in the same output. So we can say that if it returned the same result, then it was probably a waste of effort, like that was JavaScript time that didn't need to happen. So React does give us ways to opt out of re-rendering if we think that things haven't changed. And the basic tool for this is react.memo, which wraps your component and it automatically does a check of all the props to see if any of the props changed from the last time. If they haven't changed, there's probably no point in re-rendering. For class components, the equivalent is should component update or pure component. There is one other approach that very few people know about. If you return literally the exact same reference for a child element object, React will also bail out of re-rendering that child and everything inside of it. This has actually been in React for years, and even the early versions of React Redux relied on this. We can kind of make the comparison that react.memo is controlled by the child component in the sense that like you had to put that around the child component to make use of it. Whereas the same element optimization is controlled by the parent. So in this example, if I do a use memo in the parent, the element object will always be the same, and React will only render that child once and then skip it in the future. Another common mistake I see is people assume that React will only render child components if the props coming from the parent have changed. No, that's not true. Very important point. Props changes don't matter by default. React just re-renders everything recursively. The only time that props changes matter is if the child is trying to avoid re-renders using react.memo. In that case, if you do something like always passing in a new callback function, then that might break the memoization. Or passing in child elements that way, because there'll always be a new element object for the other component in there. This also means that it's basically a waste to wrap a host component like a button tag in react.memo because there's nowhere lower for it to go. There's no recursion happening below that. It's the bottom of the tree. So there's nothing to save on that process. So then this brings up the question, like, number one, why doesn't React just automatically memoize everything by default? Should we wrap every single component in our code base in react.memo? Should we wrap every single function in our code base in use callback? And the React team has advised against this. React is generally fast enough out of the box in most cases, and there is a cost, however small, to doing the comparisons in react.memo, use callback. And there's definitely cases where the comparison will always fail, and you've just wasted a couple fractions of a second of CPU time. Now, realistically, in practice, if I wrapped every single component in react.memo, it would probably have a net benefit, but it's probably not worth the effort of trying to do that in every component. It is very important in React that every time we do a state update, that we do it immutably. You need to make copies of objects in arrays. You can't just assign new values to the existing references. And in fact, mutating data almost always leads to rendering bugs. In fact, while you could sort of get away with mutating with old school class components, useState and useReducer require that you always pass in a new reference in order for React to re-render. One of the examples of this being a problem is that React.memo does reference checks. So if you're mutating the data and then trying to pass it down, it'll think nothing's changed. There's no reason to re-render. In general, React and the rest of its ecosystem expect immutable updates. If you mutate data, you are asking for bugs. Don't do it. Now, I will make the caveat here that some newer state libraries like some of the observable-based approaches, signals, even MobX, do work with a mutating syntax. They've done some things to work around those, but don't try to mutate plain data. So how do I measure my components and their rendering? The React DevTools browser extension has a performance profiler mode. Hit record, use your app for a couple minutes, and it'll show you a list of all the renders, and it'll highlight which components rendered and how long they took. Now, if you're doing this in a development mode build, don't use that to estimate exactly how long everything took, because React is running slower than it would in production. But it'll give you a sense of like, this component took longer than that other one. I should probably focus on this one to update things. There's also a special profiling build of React, which has most of the production optimizations plus the ability to capture profiling data. So that would give you slightly more realistic timings. Okay, running short on time, moving along here. Context is something that a lot of people misunderstand in a lot of ways. First one, context is not a state management tool. Context is not a state management tool. Context is a dependency injection mechanism. You pass one value in at the top, any component inside can ask for the value. It's like a wormhole or a tube. Context doesn't manage anything itself. You are doing the management by, having a useState or a useReducer. That's what's storing the value. Context is just a faster way to pass it down than going prop drilling through 10 levels of components. So updating a context value generally requires a set state in the parent component, and then you pass a new value reference into the context provider. As of today, there is no way to avoid re-rendering if you try to read part of a context value. If your component only needs value.a, but the parent made a copy of the object and then updated value.b, well, it's a new object, it's a new reference. The context provider will update, the children will re-render when they see the value. There's no way to only care about part of it and skip re-rendering. So, we know that calling set state cues a render. React always recurses through the tree by default. Context providers get the value from the parent component in state, which means that by default, if you call set state in a component with a context provider, you're probably actually going to render literally every component in your app by default. And that's without caring whether a component is trying to read the value from context or not. It's just normal recursive behavior. So how can we avoid this problem? Two ways. One is that the first component inside of the context provider should probably be wrapped in React.memo. React will get to it. You're not passing any props. It says nothing to do here, and it skips everything below that. The other approach is to have the parent of the context provider accept props.children and then put props.children inside of its context provider that it returns. When the parent sets state, it still has the same props.children element reference, and that's when that same reference optimization kicks in, and again, React says, oh, this hasn't changed, skip everything inside of here. So what about React Redux? I often hear people say React Redux uses context inside, and that's technically true, but also very misleading. React Redux has always used a different approach. It's basically an event emitter. Components subscribe to the store, wait for an event to be dispatched, and then get the state and diff it themselves to see if they should re-render. So every component that uses React Redux subscribes to the store, and this results in very different performance behavior than context. So normally, subscribing to the store is cheaper than re-rendering. It's okay to have lots of used selectors in the app. Couple quick differences. Connect wraps the component. It's kind of like having React.memo automatically. In fact, that's how it works internally. Use selector is a hook that is inside of the component. So if you want to avoid some of that nested re-rendering, go ahead and apply React.memo yourself. Almost on time, cool. A couple of future React improvements. A couple years ago, the React team announced they're working on an automatic compiler called React Forget. And this would not only improve your dependency arrays for things like useEffect, it would automatically memoize all of the elements in your component. So if it knows that it needs this piece of data, it'll only recalculate the element objects if that data changes, which basically means much, much faster component performance out of the box. So this is in very active development. They are working on it to make sure that the Facebook website works right. They had a blog post back in March where they talked about the progress. I am very, very excited about this for the future of React. On the other hand, a few years ago, there was a community proposal for a feature called context selectors. There was a proof of concept that was merged into the React code base behind a feature flag, and it's basically dead at this point. They said it's a thing they'd like to do eventually, but it's not a priority. They've been working on suspense and everything else server side, so I generally have no idea if or when they'll ever get to us. If they did, it would be very useful, but who knows? All right, that's all I've got. If you'd like more details, I have a much, much longer version of this as like an 11,000 word blog post, a guide to React rendering behavior with links to additional articles and resources. Hopefully this has been useful and will help you to write better React applications. Thank you.